Protein is a macronutrient that must be replaced daily. Proteins are a series of amino acids linked together by peptide bonds. They are composed of carbon, hydrogen, oxygen, and nitrogen. So it's the nitrogen that sets them apart from carbohydrates. The carbon side chain gives it unique structure, physical characteristics, and its name. This determines its specialized function and its shape. So again, it's this carbon side chain that makes the protein unique. So a peptide bond is just an amine group linked to an acid group. Condensation is the process that occurs when a bond is formed, and hydrolysis is required to break the peptide bond. There are 20 different amino acids. 9 of them are essential amino acids, meaning that the body cannot make them on its own. They must come from the diet. And then we have 11 non-essential amino acids, so they can be made by the body. Also, there are some conditionally essential amino acids. So, for example, tyrosine is conditional on phenylalanine, and cysteine is conditional on methionine. So what that means is that if the intake of phenylalanine or methionine is low, then it will not be able to make tyrosine and cysteine. And the body would then need an external source. And really, remember with amino acids, the primary job is building tissues, but it can be converted to glucose if absolutely necessary. So we have free amino acids circulating in the blood. We refer to this as the amino acid pool. And remember that the body doesn't really have any storage form of protein. Therefore, this amino acid pool is constantly in flux because of amino acid turnover. Most protein in our food and our body are known as polypeptides. So proteins are classified by the number of amino acids. A polypeptide will have 10 or more amino acids linked together. As you might have guessed, a dipeptide is 2 linked together, a tripeptide is 3 linked together, and a oligopeptide is 4 to 10 linked together. We can also classify proteins based on their composition. Are they complete or incomplete, high quality or low quality? Now I want to clarify complete or incomplete, high quality, low quality doesn't necessarily indicate good or bad. A high quality protein will contain all the essential amino acids. It will have some extra amino acids for non-essential synthesis, and it has very good digestibility. So it's necessary to consume protein-rich foods daily in order to obtain all of these essential amino acids. So let's talk a little bit more about high quality protein. So a high quality protein will also be a complete protein, meaning that it contains all of the essential amino acids. It does have some extra amino acids for protein synthesis. It has very good digestibility. Most of the time it is from animal-derived foods. So think things like meat, eggs, dairy, fish. Now there is an exception to that rule. Soy is also a complete protein, but a plant product. So low quality protein is an incomplete protein, meaning that it does not contain all the essential amino acids. it probably has one or more limiting amino acids. So the limiting amino acid is the essential amino acid that is missing. It's usually from plant-derived foods, but like I said, soy is an exception. So all plants except soy, um, which does not contain all the essential amino acids in a high amount. So interestingly enough, soy, quinoa, and hemp seeds are actually all complete proteins, but plant derived. So that's going to be a really important thing to keep in mind if you are working with a vegan or vegetarian athlete. So the goal is to consume a variety of foods to get a sufficient amount of all the amino acids. So there's this concept of complementing proteins. Okay, so complementing proteins are incomplete proteins that, when eaten together, provide a full complement of all the essential amino acids. So this is somewhat of an outdated theory. We used to think that we always had to eat these complementing proteins together. But now we know that really what's most important is that we just eat foods that complement each other within the same meal or same day. So it doesn't always have to be together at the same time. Again, this is why I go back to it's so important to just have a variety of protein sources. And remember that the athlete's meal plan should always take into consideration preference and tolerance. And there actually is a lot of benefit to following a plant-based diet because it does provide an adequate amount of protein. And along with that, you get lots of fiber. It's low in fat, typically lower in calories, not always, but also high in antioxidants and phytochemicals. So here's a little example of how the complementary proteins work. Again, I'm not going to put too much of an emphasis on this, but the idea here is that, if you are eating grains and legumes together, those two complement each other and you get the full spectrum of amino acids. Same thing here, legumes and nuts and seeds, then you would get everything that you need. So think maybe you would have oatmeal with nuts and soy milk, vegetables and tofu over brown rice. There's lots of different options. And many different sources of plant protein. Nuts and nut butters, legumes, beans, lentils, seeds, soy products, even whole grains. I wouldn't necessarily say that whole grains are a high source of protein, but they do still have some protein in them, especially as compared to more refined grains. And I think it's really important that we look at the variety of sources of protein because oftentimes as Americans, we're kind of programmed to always think of chicken, meat, things like that. But quinoa can actually come from a lot of other places. For example, plain Greek yogurt, quinoa, an egg, hummus, nuts, whole wheat pasta. I also think it's important to look at the protein package. Like I said, oftentimes our mind goes to something like a porterhouse steak, which is a good source of protein with 40 grams. However, it also comes along with 12 grams of saturated fat. Salmon's a little bit different, right? You get 34 grams of protein and not nearly the amount of fat. And we know that salmon also provides lots of heart-healthy fat. But check out the lentils. 1 cup of cooked lentils, 18 grams of protein, and 15 grams of fiber. You're definitely not getting that fiber from the steak and the salmon. Same kind of situation with the edamame, the soybeans. Protein has so many different functions in the body. Again, I think it's a misconception that protein is only building muscle tissue when it's actually doing a lot of different things. For example, it provides structure to our bones, ligaments, tendons, hair, muscle, teeth, and organs. It's also part of cell functioning. because typically enzymes are made of proteins, which are catalysts for chemical reactions. In terms of body functioning, our hormones are derived from protein. So, two really important hormones like insulin and glucagon. Protein is involved in our immune function. Antibodies are made from protein. Also, protein helps us to maintain fluid balance between tissues and the blood. Protein is typically a transporter molecule, so think an example of that would be hemoglobin. It also helps to maintain pH balance within your system. It can be an energy source. It can be converted to glucose for energy if carbohydrate intake is low and expenditure is high, or if calorie intake is just low altogether. So, what is nitrogen balance? Nitrogen balance is an indicator of nitrogen status and thus somebody's protein intake. So, the goal is to meet the body's basic needs for protein and supply adequate amino acids for protein synthesis resulting from training when we are working with athletes. So you can calculate nitrogen balance by looking at daily protein intake. So that's your nitrogen in. So by calculating the number of grams of protein and then subtracting nitrogen out. Now, this is a little bit more difficult because you would have to somehow calculate the urea levels in your urine and sweat. And unless you have access to a lab, it's probably going to be difficult to do that. So this is an example of an individual in positive nitrogen balance. Protein intake is greater than loss. So in this photo, protein is being retained by the body to build tissue. Unfortunately, there may be times when endurance athletes end up in a state of nitrogen loss. I know this photo is a bit extreme, but it is an example of negative nitrogen balance. Unfortunately, this individual is losing lean body tissue.